Alright, so a function in math is much like a function in the body. It's just a process for turning one type of thing into another type of thing, or a set of things into another set of things, or one number into another number. So if we have a function g here, I could put all kinds of food into g, and then what I get out is g of food, is how we would say that in math. And so I put a pear in, and I get out a digested pear. I put in cherries, I get out digested cherries. So we could look at it as a mathematical function as kind of like a bodily function here. So um, in math, the way I would write it is something like g of x. So this is the function name. You can call it anything you want. A lot of times people say call it f. I'm calling it g because that's what my first name starts with. You could call it, I don't know, m, whatever you want. And then the input variable goes here. So basically these little parentheses here, to me it looks like a mouth. Hence this analogy is working pretty well for me. So this is where this is everything you put in here, the function will do something to it. So I could have a function that says something like g of x is equal to x plus 2. So what this means is I've got this function called g, and whatever I put into it, let's call it x, here's what I'm going to do to it so that it comes out in a different way. Alright, so in math this would be called, x in this case would be called the independent variable. It means you can put in whatever you want, basically. It doesn't depend on any other numbers. Whereas this, the result, is the dependent variable. So if I were to write this as, instead of g of x, you can write it, this is function notation, you could write it as an equation with two variables. Y is equal to x plus 2, like that. And so x would be my independent variable. I can choose whatever I want to put in there. I could put in a 10 and say 10 plus 2 is 12. I could put in a billion. A billion plus 2 is a billion and 2. And then y would be the dependent variable, or we could call y the outcome, or yeah, what comes out when the function has done its job. So this is the dependent variable because it depends on whatever you put in for the independent variable. So if I put in 10 for x, 10 plus 2 is 12. So it depends on that 10, right? If I put in a trillion here, a trillion plus 2 would be a trillion and 2. Y would be a trillion and 2. So this variable is depending on this variable. And another couple words you'll hear when you talk about functions is domain and range. So the domain is all the values that you're allowed to put into the function. So back up at the bodily function here, my domain would be all kinds of edible foods. So lemons, apples, pears, lettuce, cherries. Okay, you're not going to see tree up here. You're not going to see house. These aren't things that I can eat, so they're not legitimate values that I can put into this particular function. The range would be all the outputs of the function. So if my domain here is all the foods that I can eat, the range is all the products of those foods. So digested pears, digested cherries, digested lemons, etc. So back to math world. If I have this function y equals x plus 2, or you could call that, let's make up a letter. Let's say d of x is equal to x plus 2, and that would be the function notation, which I enjoy because this definitely looks like a mouth here, so it reminds me of what the metaphor is. So if I had a function like this, there's no values that I can't put in here. I could really put in anything. So the domain for this function would be all real numbers. Okay, but if I had something like this, y equals 1 over x minus 2, there's one number that I cannot put into this function because the world will explode, and that's 2. Because if I put a 2 in for x, I'll have 2 minus 2 in the denominator of a fraction. 2 minus 2 is 0. and you cannot by any means divide by 0. The universe will swallow itself, and we'll be in a pickle. So the domain for this function would be all numbers except for 2. Okay? And then the range would be all the results that you'd get from putting all those numbers in to this function.